Okay, hi guys. So in this lecture we'll be seeing some more examples on the same, in which we have to calculate total number of monochloride products when we react following when we react a carbon compound or alkane with Cl2 in presence of HNO. Okay, so continuing on the previous examples, so how many monochloride products can we form in this case? So Cl2HNO. So one is obviously present, one is can be obviously find out here. This would be acarl, another at here, again this would be acarl, another at first at here, first would be acarl, okay, and then if we again pass it, it would be acarl, okay, and one here, it would be acarl. Total number would be 1 2 3 4 5 6. Okay, 1 2 3 4 5 6, 6 will be present. Okay, so let's actually make them and see. That we would be having something like, you can actually make them. The first would be obviously CS2Cl here, and then HCl. I'm just giving you the first example. You can draw the to be followed. So then again you have to replace this H, then twice you can replace this. On the first time when you replace H, it would be looking something like this, H and Cl here. This is one of the configuration. Another could be Cl and H here, so twice. Similarly you can form all of these and check. Okay, let's look at another example. We have something like this, passing Cl2 in presence of HNO. How many products should be formed? One here, or rather one here, 2 and 3 here, and 4 here. Why 2 and 3 here? Because it will result into enantiomers. Okay, let's look at another example where we have this compound, again in presence of Cl2HNO. First here, second and third here, fourth and fifth here, sixth, seventh and eighth. 8 total. This will contain enantiomer. 2 enantiomer will be there. This one at this carbon atom and at this carbon atom. Okay. Now let's see for this compound. 1 here, 2 here, 3 here and 4th here. Total number of products formed would be 4. Why this and these two? Aren't these two identical CH3s? No. One would be CH2Cl and another would be CH3 above the plane and below the plane, and another would be CH3 and CH2Cl. Okay, so total 4. We have seen the similar example in the previous lecture as well. Let's see another example. How many for this compound? Only 1, or rather 2. No, if you form 2, then it would be dichloro, not monochloro. Monochloro would be 1 only. What about this compound? HCl, CH2 present here, then CH2 present here, then CH3 present here. Okay, so 1 here, 2 here, 3 and 4 here. Because they would be enantiomers again. 5 and 6 here, and 7th here. Total number of products would be 7. Let's see another example. What about this compound? Cl attached here. So you can attach either 1 here, 2, 3 and 4, and 5 also. Okay, total number of monochloride products would be 5, except from this carbon containing Cl. So total dichloro would be there in a sense, but only one Cl is allowed to be attached in any of the position in this compound. Then we have something like this, CH2 and CH3. Okay, so how many in this case? So here we'll be finding 2 here, because one would be an enantiomer of the other. Okay, so 1 2 3 obviously here, 4 5 and 6, total 6 would be the answer. Okay, because the coming Cl dot can either attack this dot above the plane or below the plane. Okay, so the total number of would be, there would be an enantiomer at this carbon position. Okay, so now let us start with the selectivity and reactivity principle. So let's start it. So we have reactivity selectivity principle. So let's actually compare the bond energy of the following chlorides or HX. So obviously, as you know, that I minus is more stable than Br minus, which is more stable than Cl minus, which is more stable than F minus. Okay, so hence, as it is more stable, then its bond energy would be least, because it would have a tendency to break its bond and convert itself into I minus, which would be the highly stable cation, anion. Okay, so the bond energy, so obviously the bond energy of Hi would be the least. Okay, so just for the factual purpose, bond energy of HF is 103 kilocalorie per mole, and for HBr is 81 kilocalorie per mole. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing the free radical reaction in case of all the 4, and then we'll be comparing on the basis of selectivity or reactivity principle. Okay, so till then, good luck and goodbye.